In this example, the equation for the terminal side of theta in standard position is 2x plus y equals 0, where x is less than or equal to 0. I need to find the exact values of the 6 trigonometric functions for theta. So remember, an angle in standard position means the vertex is at the origin, the initial side is along the positive x-axis, and now I need to determine the location of the terminal side. It was stated the terminal side is given by the equation 2x plus y equals 0 when x is less than or equal to 0. The first thing I need to do is show my terminal side goes through the origin. So when x is 0, substituting a 0 in here, I get 2 times 0 plus y equals 0. 2 times 0 is 0. 0 plus y is just y, so I get y equals 0. So I know my terminal side goes through the origin. Now all I need is one other point on the terminal side. It doesn't matter which x value I pick, as long as x is less than or equal to 0. I'm just going to pick the easy one of x equals -1. So when x equals -1, substituting it into this equation, I get 2 times -1 plus y equals 0. 2 times -1 is -2 plus y equals 0. Adding 2 to both sides of this equation, we get y equals +2. So when x is -1, y equals 2. Plotting this point, left 1, up 2. There's the point -1, 2. Now I can draw the terminal side starting at the origin going through the point that I just found. Here is my angle theta. And remember the little right triangle associated with that? This is y, this is x. I need to find r. For this point, x is -1, y equals 2. And using the Pythagorean theorem to find r, I have r squared equals x squared plus y squared. X was -1, so that's -1 all squared, plus y is 2, 2 squared. -1 all squared is +1, plus 2 squared is 4. So r squared equals 4 plus 1 equals 5. Remember, r is always positive, so it's going to be the positive square root of 5. So I'm going to use x equals -1, y equals 2, and r equals the positive square root of 5 to find all 6 trig functions. So starting with the sine of theta, in terms of x, y, and r, that's y over r. Y was 2, r is the square root of 5. That is a perfectly good answer unless you're required to rationalize the denominator. If you're required to rationalize the denominator, what you're going to do is you're going to take 2 divided by the square root of 5 and multiply numerator and denominator by the square root of 5. So I get 2 times the square root of 5 over the square root of 5 times the square root of 5 is 5. So if you're required to rationalize the denominator, that is your answer. Next, the reciprocal of this function is the cosecant of theta. Remember, which is 1 over the sine of theta. And I'm going to take the reciprocal of this version of the answer. If I tried to use this one, I'd have to rationalize the denominator again and then reduce. But if I take the reciprocal of this answer, I just get the square root of 5 over 2 that I don't have to simplify anymore. Next, looking at the cosine of theta. That is x over r. X was -1. R is the square root of 5. And if you don't have to rationalize the denominator, leave the answer like that. But if you do, it's -1 over the square root of 5 times the square root of 5 over the square root of 5. So I get -1 times the square root of 5 is negative the square root of 5 over the square root of 5 times the square root of 5 is 5. Its reciprocal function is the secant function. The secant of theta is 1 over the cosine of theta. And I'm going to take the reciprocal of this version. So it's going to be the square root of 5 divided by -1, which simplifies to negative the square root of 5. And lastly, I need to find the tangent and its reciprocal. So the tangent function is just y over x. Y was 2, x was -1. 2 divided by -1 is just -2. The reciprocal of the tangent of theta is the cotangent of theta. Remember, that's 1 divided by the tangent of theta. I'm going to take the reciprocal of this fraction, and I get -1/2. So that is the value of the cotangent of theta. So now I've found the exact values of all 6 trig functions for theta.